Okay, very cool. Welcome to the stream. Today we're going to try to get closer to emitting actual mermaid diagrams from the local run of the remote interpreter. So last week we were able to emit a stream of text events for when tasks were forked and awaited, and that was really cool to see. But we want to be able to dynamically draw these diagrams. And so we need to start turning our stream of text into hopefully streams of like nodes and links. So that's the goal. We'll see how far we get. And let's take a look at this project. I'll run kind of like just what we did last time, because I think we have a main method in scope here that may help us out. So I'm gonna run.
Can you pull up the code you're about to run so that we can see what the...
Yeah, let's do that. Edit test fork. Oh no, that's not it. Test create.
Yeah, Paul, were you here last week, Paul?
I was not.
That's
Yeah.
right. You would have. I would have remembered if you were. We ended up staring at the output of this for a while, trying to explain how things come out in the order they do here. It's pretty crazy, but it's like you can actually figure out what the what the cooperative concurrency algorithm is just by looking at what gets emitted.
Oh, yeah? Nice.
Okay, so
Yeah, I think it's fairly greedy. Like when you fork, I think it might, at the moment, just kind of always
Well,
keep
the one
big.
thing that you could glean from this is that when someone completes something that is being awaited on, you switch immediately back to the awaiter and don't let the thing that fulfill the promise keep going, right? I don't know. Anyway,
This all might change. This will probably also change. We have at some point.
Yep.
Well, okay, so will this code somehow work, or even if we totally change how the pure interpreter works?
No, this is our own pure interpreter. We took the pure interpreter, we ripped out channels and stuff like that, and like re-implemented it with some stuff on the side to emit this. Like we re-implemented in terms of stream. You want to pull up our interpreter?
yeah.
I say, okay, cool. Well, I don't want to take you off course, but
No,
I'd
no,
be curious
no. I
if
think
it
we
can
all
be
need
done
this
as
to kind
a
of get us back
decorator.
to remind us where we were.
Yeah, I think this is good. Recap. Let's do edit run dot simple. Yeah, this remote pure run dot simple, because it rhymes with dot imple, like the last one. It emits a stream
Right.
of text, and it does do the computation, and then we just to list the stream.
So I bet you could do this with um, I don't know, I've been calling it like a decorator, a handler decorator, where it just handles remote into remote, uh, but then just sort of is emitting these other things on the side.
I mean, I'm not sure because we're actually like we emit like when this handler exits, and I mean, I'm not sure.
Yeah. It might
Oh,
Uh,
not be possible, but I'd be intrigued if it,
sure.
yeah. I would say you should keep going on what you've
Yeah,
been doing, but
definitely, definitely.
okay. Yeah, but I'll we'll bookmark that
Like
idea
start
because I
over.
think
All good.
that would be cool to try. Because then
Yeah.
it would be more flexible if y'all change the underlying remote interpreter.
yeah.
Yeah. This also would not work if you have more than one location, because right now we're just sort of like shoving everything into the location number one because there's only one. You know, the moment that changes, it'll look weird. So, okay, cool. Anyways, this is the giant function, and we were going to look a little bit more about what test create log produces. Oh. Expecting comma. Does it not like my...
Talking about line 200.
Oh, line 200. All right. Okay. I'll make a note of that. We'll have a round trip error bug later. Anywho. Okay, so test create log. We enter the remote run. We log the location, first thing. Task 0 is like the root task, the starting task. It forks one task. It forks a task to add 2 plus 2. It forks a task to add 3 plus 3, and that's this third one. It waits for 1. The needs waiting on is...
That was saying that needs waiting on. We were either saying needs waiting on or doesn't need to wait for based on whether or not result for that task was already there.
Ah, okay. Okay. And then it finishes task 1.
No, then it gets a result from task 1. This is where it was curious. So then, and it's also a little bit strange because what's called task 1 on the left is actually task 2 on the right. But yeah, so what happens is the root task 0 needs to start waiting, and then it actually gets a result. And then the next thing that happens is that task 3 finishes. And then task 1 finishes, which was the odd stuff that we took a long time to figure out how we got to there. But essentially, once we start waiting, task 1 starts up. It provides a result, which immediately gives the thread back to task 0, who then and then I don't know why 3 finishes next.
Are you asking about 0 starts waiting for 3, or...
No, I wonder why we see the end of task 3 as the next thing we see. Bo, I know why. It's what? Go ahead.
I was just asking, for that line in particular, who's reporting end of task 3? Like, from which task does that get reported?
That's when the task 3 handler exits. So that's like when the handler is all done. So that's the interesting thing, is that like we haven't seen 1 finish yet. And that's because like as soon as it provided a result to thread 0, thread 0 took over, or no, once it provided a result once it was giving a result, I think what happened is we went and grabbed whatever is the next thing waiting to run, which was task 3, which had never had a turn yet. And since it has nothing to wait for, it just runs to completion. So task 3 just finishes, and then we pick a new thread to run, and for some reason 1 is the next thread that run, so it finishes. It had provided then, then it can go and await on task 3, but task 3 already finished, so we don't need to await, and then the last handler exits. So yeah, the end of task things are like when the handler has nothing left to do, which is not that's not the thing providing the result. Like that's like providing the result is something that handler does. And then later it might exit. Like that thread that was handling that task that logical thread would exit. I don't know if that all made sense. It makes sense to me now. But
Where does the
part is like when the task 3 ends in the middle of all that. And that's the one that's the most mind-boggling.
where in that effect handler does the reporting of the actual result happen?
Oh, it is. That's actually the line after, isn't it? So I got that wrong. That is weird. Is it that complete? Underscore, is that the thing that's actually providing the result?
Let's take a look.
It must be. Yeah, it must be.
Complete.
It's weird. So obviously we're reporting that before we actually provide the result. Then I don't understand how. I don't understand how we ever switch. I don't understand how that trio8 comes out. That trio8 and 1. That trio8 comes out like the 5th log line. I don't know how that comes out before the end of task 1 log line comes out.
And I remember last time we looked at the fact that sleep doesn't actually have, there's no causality step to allow sleep to know that it should sleep until after something else, and it just puts it to the back of the queue. And if there's nothing actively in queued, it'll just pick that up.
Right.
Yeah.
Anyway, this might not be something we want to dwell on, and we might want to just start emitting diagrams.
Yeah, maybe a diagram would help us understand it.
Yeah, I mean, I think it shouldn't really matter what linear order these come out in.
Yeah.
It's just like whatever implementation sort of details of the scheduler. So yeah, we just want a DAG.
Yeah.
Of some
sort. It's one of those, like, once we got this stuff emitting out, we're like, okay, how do we know this is correct? And I'm like, well, it kind of doesn't really make sense that what order these are coming out in, but it works.
There's one.
If I remember correctly, I think this current scheduler is pretty simple. Like, it just, when you call fork, I think it just immediately starts running the fork, I think. And it basically never like yields unless you it never yields unless you await something that is empty, or unless you're awaiting a task that's empty.
Right.
And then it just, like, puts itself in the back of the queue, and then other stuff runs.
But we don't understand why the trio8 end can possibly come out before an end of task. But
I don't know.
Yeah. Anyway.
There's one little detail in drawing the mermaid diagrams where causal ordering is going to matter, which is that in order to represent, like, returning back to, like, the home or the sort of root task, you can't just reuse the same ID for drawing something lower down in a mermaid diagram. So an example of this would be, let me switch, change windows. An example of this would be like this drawing, where, like, this drawing obviously doesn't show that task 3 was forked and awaited after task 1 and task 2 have been forked and awaited, which is fine if all you want to show is just, like, where tasks are relative to the location in the root, but it's maybe not as illustrative as, say, something like this, where you've got root, task 1, task 2, coming back to root. It looks like it's the same node because I named it the same, but we're going to have to sort of, like, increment a counter or something when things kind of get returned to the root task. But we can name it the same so it'll look pretty for our users.
This looks really cool, by the way. This is the first time I'm seeing this visualization, but if we could produce this in general for even for multi-location computations, that would be incredibly useful. And yeah, super cool.
Yeah,
or even if you can run it locally and simulate the remote stuff and get a graph of how it would have executed on a 10-node cluster or something like that.
Yeah.
Yeah.
I really want my goal is to make this local interpreter work enough that I can integrate it into the distributed programming exercises so people can be like, I don't understand what's happening. Okay, wait, no, let's like switch out the interpreter and then they can help, like they can self-serve kind of debug.
Okay, so do you want to either make a program that matches a graph you already have or something like that, such that we can then like see what we're emitting and then like try to like munge it into the thing that we want it to look like?
Exactly. Let's
Okay.
do that. Okay, I gotta swap back to this other thing.
Yeah.
Change windows. Go live. Okay, cool. So let's pick a graph. And I had one in my little write-up. Okay, I want this example. I'm going to put it at the top of the screen here. So this 3 tasks example is basically the diagram I was just showing, where you've got fork task 1, fork task 2, await the 2, fork a 3rd task. And so we want to see that like sort of diamond shaped shape. So that's the goal. In order to do that, let's see what it would look like in Alvaro's library. We can just draw out the diagram, make sure it's drawable. And I believe I actually have that too. Let me pull that up. Three tasks, flow chart. Okay. Let's see, is everything in scope? Second argument. Oh, you know what? Okay, so this is saying we've got 2 links, a fork style link and a wait style link. We've got a root node, task 1, task 2, the second instance of root here. We fork task 1, task 2, we await them, then we create task 3, and we need one more link. Okay. All right. This is a version with the DSL. We're probably going to be creating, so in Alvaro's library, there are sort of DSLs for drawing the diagram, and then the DSL kind of like creates an actual instance of like a node type or a link type. We're probably going to be emitting the actual data type as opposed to using the DSL, because I think that would be a harder integration. But this is just to get us drawing the diagram. So I think it's just flowchart to text. Yeah, okay. Okay, it makes this string, and then we go over to Mermaid.js.
Do you want to maybe run that instead? So it,
Oh, make a main method?
yeah, and maybe get rid of the other watch expression. Yep.
Yeah. And
You can just run temp main. I forgot. Yeah, that's fine.
okay.
Oh,
Oh, now I have to print it. That's right. Ugh. Now, if we run temp main, hey, that looks like a mermaid diagram. And let me change windows.
There we go.
You know what? I think we're missing one more link, which is the link from task 3 back to the root. So, where are we? Fork link root B task. We are.
Do you want to switch back to the other window?
Yes. Change windows. This guy. Okay. I just added this fork link task 3 to root C. And I'm just going to confirm that that's right. Yep, that's right. Okay, so the diagram that we want to draw is this beautiful text right here. According to the conventions of this library, it looks like you create your nodes and then it looks like you can interleave creating your nodes and your links in this DSL. So I think that's going to be okay.
Okay, so right now we're streaming text, and next we're going to switch to start streaming. Do we have a data type that we're going to stream out instead?
Yeah, it's whatever this node function actually makes is, I think, the thing that we're going to...
Wait, is that just for making the nodes, or do we need to stream... Like, do we need to stream something that's our own type that could be either a node or a... What's the other thing?
a node or
Or are they
a
all
link, I think. So... Okay, so if you're a node, you can either be a leaf, which is like a box, or a subgraph, which is a box that contains other nodes.
Yeah.
Interesting. Okay, so there's this notion of a node ref.
Would it work? Would it work to just handle directly into that DSL? Or you said you were worried about that being tricky, but this API
Maybe.
seems pretty good.
So the DSL takes place in the context of this flowchart.create ability. And maybe it wouldn't be.
What is the... Can we look at what the draw flowchart thing looks like?
Yeah.
The ability? Yeah. Okay.
Okay, so it's add link or add node.
Yeah, maybe we can just handle right into this.
Oh.
Like, forking a task is adding a node, and adding a link, and awaiting it is just adding another link.
Would that mean changing all? We wouldn't need to go through the stream ability. Is that what you're saying?
Instead of stream, maybe we can just
That's
emit.
right.
Yeah.
Yeah. Okay. Let's try that.
Yeah.
Okay.
Do you want to...
Let's drop a live share link.
We have stream text all over this place.
Yeah.
Do you want to... do you want helpers?
Yes. I just put a live share link in the chat.
Oh, you did. Okay.
Stream text.
I'll join.
Okay, and we want Draw flowchart. Yeah, we had to work somewhat hard to get the local remote interpreter to compile with our stream decision. So I'm going to change all of these to draw flowchart. Draw flowchart. Draw flowchart. Huh, I'm surprised this compiled. Draw flowchart. Draw flowchart.
It says waiting for host approval.
Oh, I have.
Do you have any?
I don't see any.
Weird. Okay. Let me
There are
try
no
something else.
participants. Is it the same link? Yeah, it's the same link. Okay.
I'm in there.
Okay, I see Stu.
Okay, so what was the name of the ability we're gonna handle into? Draw what? Draw flowchart.
Yeah. Oops. Hi, Fabio. We are adding a flowchart ability to a copy of the local remote interpreter. We're trying to make a diagram from a trivial test case of forking a local computation. Okay, where are we? We are on.
All right, emit. That's something.
Oh, yeah, we got a bunch of emits still.
So that is this is what an add. Right, I'm on line 154.
154. Okay. Yes.
We're gonna await. So that's where we're gonna add an arrow, right? We're gonna add a. I gotta pull up draw flowchart somewhere locally.
Okay.
Does end of task, do we do anything for that? I don't know if we do.
No, I think we just put that in. I think that's when we were. No, we could probably get rid of that.
Does end of task?
That's not like a graph element. That's just kind of. Basically, the end of task will be recognized when you await it
Yeah. I think
in the graph.
we just want fork and await are the play. We need to. I think fork and await are the two places we need to do something, right?
Yeah.
Okay, I commented out the emit in.
Right.
Yeah, I guess that's
So
probably a good thing to try first. It's just
where's Alvaro's?
oh, it's under his name, public, and then it's called Mermaid, and within Mermaid, it's the Flowchart
Yeah.
sub namespace.
What is it? Draw. What's the name of the?
Draw Flowchart is the name of the ability.
Okay, so at the await, we want to add a link, but we can't. To add a link, what is a link? I assume
Yeah,
a link
we need
needs
to have a
node refs. So how do we get node ref? How are we going to be having a node ref? So we added this second task ID,
yeah
which was the current task. We really want that to be like the current node ref, right?
yeah. I think we turn the task ID into a node ref, and then the current and then the awaited task become the two sides of the link.
Okay.
And then what is the link props?
Are we going to need, okay. How?
Props. Oh, it's just styles. Link props is
How do we node ref for the thing that we're
Okay,
awaiting?
I'm actually sorry. I'm changing my mind. I kind of think maybe stream is the way to go because otherwise we're gonna have to add like some handler state to
We're gonna have to pass it like a dictionary around everywhere.
yeah. Whereas if we just sort of emit not stream of text but stream of something, then we can just write a little stream handler that folds over that with like an accumulating map or something to
Yep.
something.
Ooh. All
okay.
right, can we nail down what the type of that thing is then?
Oh yeah, let's do it.
Okay.
What?
Want to go meet you at the top of the file?
Well,
What do we
Like diagram entity.
something? Yep. All we need is like fork and await, right? Is that all the events we need to emit?
what are the arguments to fork or
I think it's from task to
to?
task or something like that. Like parent task, child task.
is it this?
I think it's that. And I think
Yeah.
it's a yeah. I think it's a homomorphic await. Yep.
What's await?
I think it's homomorphic. I think it's task of. I think it's which task waiting on which task.
Okay, so sorry, what are the two arguments?
Parent task,
Done.
child. Okay, for fork is going to be parent and child, so it's going to be that task A forked task B, and then await is going to be awaiter and awaitee.
Oh, okay.
Okay, so now everywhere we have either stream text becomes stream trace event and draw flowchart becomes stream trace event, right?
Okay. Start at the bottom. Okay, we got a stream of trace event. Stream trace event. Where are we missing one? Oh, here. Okay. And where else are we missing? Okay, stream trace event, stream trace event. Okay, and 141, finalize. Where is finalize helper function?
I might need to pull it in.
I think I got it.
Okay, emit.
Yeah, okay.
All right, so now we have, this is just, this try await, we just need to emit once at the top, right? We can get rid of this emit, I think.
Yeah.
We want to emit a, what is it, trace event dot, what was it called?
Await, just trace event dot await, task ID, where awaiter
And that,
comes first.
yep.
Okay. And then we don't need this one.
No.
No, we don't
Nope.
need that one at all. Okay.
Just need,
Stream.
look up tab.
Okay.
Somewhere we're still emitting text. or
We're at the try forcat,
Oh,
so
yeah.
we
This
should
one's-
do event dot fork from is, so current is our from, and TID is the new one. Yeah. I think this is right. There's a couple of task IDs here for when we're forking though, so. Current comes from the handler state. Yeah, okay. TID, this increments it. There's a read-only one too though.
Oh, where you're,
I'm
sorry,
I'm
calling you now.
in
Where,
try forcat.
okay,
line.
I'm with you. I think we're good.
Okay, okay. I'm just making sure we don't need to do anything with this read-only task ID. I don't think we do.
No. No.
Okay.
They're the same.
Okay.
Current problem.
What happens if someone awaits? I mean, this is a thing you can do. You can await your parent task.
We're gonna emit the link. We'll see how it draws it. Should be.
Wait.
I don't know.
When someone emits or waits your parent, what do you mean?
Sorry, if someone awaits the read-only version of the task, that thing, I guess. I'm not sure. I don't know. Most programs don't do that, I don't think, but
I don't know. We'll find out.
I
All right.
guess
So what do we? Go ahead.
I don't know why we have a read-only version of our task thing and our tasks.
Because you can't complete your parent task. That's why it's read only. You're not allowed to, like, any task you have in hand that's not yet completed, should be able to complete it. Like, say, I have a result for this task,
Okay.
but you're not allowed to do that with the parent task. It's read only. All you can do is wait for it.
Oh, okay. 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 Oh, I gotta fix this.
Lots to kill your parents in this
321.
world. Right. So that's like that. I think now we're at the end. This is like, what are we doing with our results?
Okay, yeah. So we've been streaming. It's not right. Actually, does this just kind of work? Do those types line up? Okay. This is what it draws. For a test create log, which only has 2 tasks and it's just forking and awaiting. So 0, 3, 0,
Okay.
3, await, 1. Okay, that makes sense.
So now we just gotta like do fold over this. Every task we see, we do an add node. Right?
Yeah, where are we? Do it here.
you
Okay.
can just fold left directly over the stream.
Oh, that's true. I don't need to await it.
Yeah.
Okay. Does fold left also return the result, or I guess we could just return it?
Good question.
How come? Do I not have stream? Okay. Oh, there's fold with result.
Oh, I see. Yeah, you can't really fold right over a stream.
Yep.
Okay.
There's only one.
'Cause- well,
We wait until the end of the stream.
you could if you had like a lazy function. Anyway.
Okay, so we'll just use fold with result.
Yeah, that looks good.
Okay, so B is the trace thingy. We're gonna make that a function. And
So I'm gonna say, well, okay. We want like a helper function that's gonna like run inside draw flowchart, maybe.
yeah, what
No.
were you saying, Stu?
No, never mind. Well, I feel like we're gonna want like a inner. I feel like we're gonna want something like this that is doing. And we're gonna want to call that. No, I don't know.
Yeah, let's do that.
Yeah.
And then we can do flowchart.create.
And then in here we can do the fold. And we're gonna want to handle.
What line are y'all?
What?
324.
I'm good. I'm good. Yeah. This is just sort of like a for each. Right? Or no, sorry, what? I don't know. What is the result?
What are we hoping?
Yeah, where is, let me find the example, actual flowchart drawing. I think it's up here. I'll move it down. Oh, okay.
That's yeah.
I
Okay.
was weirded out by the go being inside. Like, I thought it was recursively calling that, but got
I'm not
it.
sure. Yeah.
I kind of want to create these helper functions.
Are we gonna have to fold over it twice, like once to create nodes with some kind of memory, or do we have to do some kind of dictionary thing here?
Do we?
Each time we have to create one node for each task,
Yeah.
and then we need to
Can't we
create the.
just do that on fork?
Yeah, I guess so. Yeah. But the very first one is special. So maybe we add a root node or something. I don't know how this.
The very first one is. Oh, like.
Like, is that on your screen? No.
I actually think that is unit.
Which is the result? Is it the second argument of fold with result?
I'll look it up.
Fold with result, yeah, is the second argument.
Okay.
So it's not unit for us.
No, we actually need to return the result.
The result is going to be, we want the result, the A result.
Okay.
I think this is right. It's just flowchart.create. Does that assume unit?
It does, yes.
Do we get, I feel like there is a version of LSP that gives us type signatures, but on hover.
Do you have to build
Oh, I
from
see it.
source for that one?
Okay.
I don't know if it's in.
No, I actually see it. It's working.
Okay.
I see. Well, that's kind of a bummer.
Wait, what's the
Because flowchart.create requires you give it a thunk that returns unit.
Oh, okay.
So we don't. Yeah, like I could imagine a version of flowchart.create that would it would return a pair of like a flowchart and the A, whatever A is returned from the from draw flowchart. The computation, yeah.
Right.
I see.
So
Is that hard to change?
Oh.
maybe we could just write that.
Yeah.
Yeah.
Yeah, it totally would be. It would be simple to change flowchart.create to return the tuple. That would be trivial.
Or yeah, we could introduce like a flowchart.create.impl or something that,
Yeah.
or dot result, or I don't know.
This is the,
That's
let me indent this properly. This is what flowchart.create is. You want flowchart comma A?
Comma, sure, A. Yep.
Yeah, that looks
Wait,
good.
let's make it this. Whatever is the same as.
Oh yeah, I guess what is to stream with, or to list with result? What is the order for that?
That's it. That's it.
Oh, okay. Because it's annoying if we keep swapping them.
Yeah.
Okay. Orientation. Draw flowchart A. Flowchart A. Okay.
Yeah, should we just change the return? The return type of this is now just flowchart and the failure, right? Or and the either. We're not returning a list anymore.
Right.
So I think it's literally just
Yep.
Yeah.
that. We're done.
We're done modulo a couple
We
to
got to
do.
fill in the to-dos, but
I'm trying to figure
and
out
it looks like
is there a doc in here somewhere? Match with. Ah. What is happening here? Here one is flowchart.
we got to change the signature on 322.
Oh yeah.
Oh, yeah. This has to be comma A.
Oh yeah, that too.
And so, fold with result, the second argument needs to be something of type
Oh,
A, but we don't, like, what's the fallback? Or like the,
it's a.
No, I think this is right. It's like we're just using like for each over the stream. We're not actually accumulating a value.
Oh yeah, but
but,
oh, it's complaining about Go. I'm in the wrong type.
okay, let's see, first, has type E. Has type
Let's try giving it a little help.
Wait, does it need a? Does that? We're flowing over a unit. This is producing a unit, then, right?
This is producing a unit. I bet that's it.
We should be producing a unit. We should be producing a. What? What I expected orientation.
Well, no. The
Oh.
fold, yeah, it's kind of confusing, but I think unit is correct.
Okay, and we do need top.
It's definitely not what we're definitely can't be returning a unit.
We just want to return the result of the remote. We don't really want to return a result from the fold because instead of returning a result, we're just emitting these draw flowchart commands.
Right.
You know?
So what are we doing with our flowchart actually? Oh, we're just returning it. Okay, so this fold is what? What is this returning? This one side of this is a unit that we are going to ignore, right? And the other side is the result.
Yeah. Okay.
Okay.
Does that not type check?
It says it needs the G blah 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 ability, but only has access to draw flowchart. Oh, do we need to make the draw flowchart create with result ability polymorphic? Just say create with result.
Yeah, maybe that might be it.
Okay, yeah,
Yeah.
this is better.
This is bugging me. Okay, ship it. Oh, all right. Well, we still have to fill in the to-dos.
There's like a capital.
Oh,
Where's this capital L flowchart coming from? 351.
That's long.
Oh, it's because we don't need this trace event anymore. Okay. Three. 20. Oh, my bad. I was fussing with something. Okay. Does it? Okay. Yes. This is what we expect.
Now we just got some
We
to-dos.
got some to-dos. So when we fork is when we create the node. And then when we await, so forking is I create a node and then I create a link. And then await is,
Do we need to create a parent node first? Root?
I think we do.
And how do
should we create? Well, could we just like maybe do we need to accumulate like a set of nodes, or I don't know, that we've already
map
created or
a
something?
map of like node ID to or task ID to node?
That seems like a thing.
A map of task ID
To
to
node.
node.
Maybe that replaces our unit that we're folding over.
What's node?
Uh, it's literally, I think it is called node.
Oh,
It's
okay.
flowchart.node.
Okay. So what do we do in fork?
We create the node using the draw. How do we create a node? What is node?
I think the
So do we want to
DSL is
create
just
like a root
node.
node?
Node can either be a leaf or a subgraph. I think we always want leaf, which takes a text and a shape.
I I think
Okay.
if we don't ever
Do we want
create the subgraph, we won't ever get like the location information. But maybe that's okay for like first pass. So this map idea, when would I guess I think of the task idea as being one to one with a node, but I could be wrong about that.
Oh, you mean we might emit the same node more than once in the on the graph? Is that how you had your graph?
Well, I guess what is the map mapping? Like what is it tracking? Are we
Which No, what task ID maps to which node that we've already emitted?
What task ID maps to which node? Like what it links back to, like its parent, or
No, we just like if we see that task, like if someone starts awaiting a task, we need to be able to emit a link which has a node ref. So maybe it's supposed to be node ref actually. I think it is supposed to be node ref because when we emit a link later, when the awaiter's down here, we're gonna need to know the two node refs of the thing. What is awaiting what?
we need to know what is awaiting what, and that information is not available from awaiter and awaitee.
Right, we're gonna need a map to say, okay, I see what task is awaiting which task, but what node in the graph is that, so that I can emit which node refs are those, so I can emit a link here.
Because the task IDs are different than the, I don't know, diagram node IDs, right?
Oh, I guess
So
I was thinking to just use them. Like task ID to
okay.
text, and then like no becomes node ID.
But we need a node ref, which I don't know. How do we? I mean, which we don't get until we add a node, and it gives us back the node ref that we have to later use to refer to it when we create links. That's why we need this. This should be node ref. So we're gonna say if we don't have one, we're gonna create one equals add node with our n, and then we're gonna our map is gonna go from the node ID to the node ref in nodes. Why isn't that blending?
Do you want the sum?
Yeah, we have to do that. Then well, no, that's just return the map. Nodes. But I don't know why we're not type. What's the...
I think it's just because there was a to-do hangout at the bottom.
Okay, do we have to do the same for the... Do we have to do the same for the
For await.
child, actually?
Yeah, I would think we need to insert both.
No, I don't know. Wait. Which will take a... It's going to be just a add task. It's going to take a task ID and a map of... What's happening?
What?
What happened? Oh no, I think because we share a buffer, maybe something happened. I'm gonna fix the indentation really quick. Okay, go ahead.
All right, this is where we lost it, huh? Okay. I can write it again.
Hold on. Oh, I think I may have messed up all of your indentation. Should add task and go be inside the run diagram function? Are they closed over?
Yeah.
Okay. My bad. Fix that. I think it's node.leaf. Yeah, okay.
Okay, and then so now for parent child, it's just
Do you guys think it might be handy to add an ask ability to be able to thread that map of task IDs to node for so long?
Overkill. Okay.
okay. Awaiter OAT. So now we gotta say
Yeah, we gotta add a link in here too.
Yeah.
Where's the link?
what we're doing down here. It's gonna be from ref equals to ref equals, and then it's gonna be add link.
No, but you need to do that in fork as well.
Yeah. You need an
Oh, you're
arrow.
right. All right, so then we really just add link task ID map task ID node ref map, and that just has to draw stuff, right?
I think it's got to return the map as well.
It doesn't change the map.
Oh no, it doesn't change the map. Okay, fine.
Link. Oh, we need link props to link props to make a link. Find
Not
props.
that yet.
Okay. Link. For link props, you
Want to have like a different.
what was that?
Yeah. Well, aren't there like two kinds of links? One that's like a fork link and one that's like an await link.
Oh, yeah. What? Yeah, where is that? Oh, that's what I need. That's yeah.
I mean, the only difference I think is what you put first.
I just need. Didn't you have an example of creating the links the way you
Oh,
want?
yeah,
How do I create
it's where did I put it? Where are you? Oh, so it's up to 293.
All right. Oh,
Looks
what
like
is that? That takes. Wait, what is the type of fork link?
fork link is a
Oh, that's a node ref.
node ref to unit.
Perfect. Okay,
Yeah?
okay. Yeah.
Okay, I'm going to delete my annotation here.
Let's take the label to add link.
The label, oh, like just like the name
Then we
fork.
can just, yeah.
I see.
Okay, so the label.
From to. Our
Just to make this less confusing, I'm gonna do this way.
this has to be a node ref. Okay, and one is unit. Oh,
Type checks. Ship it.
As a flowchart, can you paste that into a fancy thing?
we have to call two text on it.
We have to. Right.
So we got two text logs. So we want to do @1.
Can you put it in a main though, so that you can print line it?
Yeah. Oh, I name everything temp main. Okay, flowchart. I will change Windows to. Okay, let's see. What do you look like? Oh, okay.
All right. Arrows are backwards on a weight or something. Or no, is it? I don't know.
Yeah, I think we just for a weight, the argument order just gets flipped. Where are you? Oh,
Also, don't we have to do something to like create another instance of the,
Yeah, what's the
you know,
diagram?
to like have it keep just going down the diagram when you await?
yes.
So that's creating
How
a
do-
different node for the same task, right?
Yes.
Right.
Oops. Okay, this is a little better.
It's a thing.
The arrows, the arrows are doing the arrowing.
I feel like we could do something about all those zeros, but that's
We can, yeah, the two text function on node ID can be fixed.
I'm wondering if even the original diagram was correct, because the way we talk about it is task 0 forks to task 1, and then also task 0 awaits on the completion of task 1. Like, do we have a good conception of what semantically correct and meaningful diagram looks like in the acknowledgement that we have no way to conceptualize sequencing? Like, there's no concept of time.
Right.
Like, I'm wondering if maybe we can expand the scope to this to capture the current execution state of each one of these nodes. And so kind of like, how in like actor models, you talk about the behavior that it has. So a combination of the state and the thing that it's doing. And if that might make this more semantically meaningful in acknowledgement that there's no such thing as time in these diagrams.
I guess what information would that entail kind of adding to the diagram? Would that be like when you say the state, like do we need to capture more metadata about the tasks that are being forked, or
You mean
Like,
uh
I wonder if we can have maybe two separate. So we have node 0 starting at the top, and node 0 is currently doing nothing, and then it forks both task 1 and fork 2. Task 1 and task 3. And then we represent a new node of task 0 in the awaiting state, and it's awaiting on task 1 and task 0. So you'd see so task 0 forks, so two convergent forks to task 1, task 3, and then two converging awaits into task 0 in the awaiting state.
I think I understand what you're saying. So that would be, we want to do something like this. Is it showing this location 1 diagram?
Yeah, I think that captures the correct semantics. And the only notion that we have of time is the state transformations in the diagram. Right, since it's implied that causality moves downward, but there's no actual notion of time and things happening after.
Yeah. Yeah. So
yeah, I feel like
want
go ahead.
this. I want this structure where even though it looks as if, this root is quote unquote named the same thing, behind the scenes we can like increment an ID counter and then give it a label that says the same name. So breaking apart
I
that.
think it's that. I think just on await, you basically create a new node for the basically join point. I don't know. It might be tricky to
How do you know that you already have? Oh, I guess you can have like
yeah.
we have a map of arrows in and arrows and one of arrows out or something like that.
Okay, so this diagram I don't think we can produce in that there actually is an order that you call await on the root for task 1 and task 2.
So
So
technically,
what I would
we would. Sorry, go ahead.
yeah, you would actually have root twice. The first, I don't know which task you await first, but say it's task 1, so you'd have task 1 takes goes to root. And then you'd have another copy of root that pulls in task, that awaits task 2. Basically expressing that you actually do await the tasks in that order.
In the remote ability, is there a way to express like in applicative style, like no sequential dependencies await on multiple things? I think that's the structure that we actually want to capture, but I don't know if that's easily expressible.
I mean, the API is very, the API doesn't let you say that. You could call a function, but then that function has to make a decision about what order it's doing things in. Because it, you know.
So I think what we're deciding is that this actually fits much better in Alvaro's sequence diagram instead of the flowchart. Right.
I guess you could. Well, I don't know. You could, like, if you just have a chain of awaits, you could potentially sort of collapse those to a single node, as opposed to like a sequence of calls to await. But see that as well. Sort of depends on like what information you're interested in.
Yeah.
Like sometimes what's on the screen is fine, and then sometimes you actually do, you might actually care.
Hey, Alvaro, since Alvaro joined, Rebecca, you want to show them what we got done? Do you want to rerun it? Because I changed it a little bit.
Oh, yes. Okay. We have news.
So we have, yeah, we're doing it. We now have, when we fork and await, we're drawing an actual accurate diagram. It's not the diagram we wanted, but we're drawing a diagram.
Oh wow! Yeah, that's awesome.
Yeah. So, progress.
We're getting there, but I think Paul's point about like whether or not we can produce, or what is the semantics of a quote unquote correct diagram is really interesting, because I've gone back and forth between like, do we do sequence diagrams, do we do graph diagrams, do we do Git branching diagrams, like what is the best way to model the fact that task 0 forks out to 2 tasks and then they're awaited.
Which actually, I'm not sure why it looks like this.
Yeah, I'm not quite sure this is right, but
Oh,
it is a diagram.
Yeah. It looks different than that.
We have a question. Why do we have task 3 and not task 2? That is
that's because we named them, although in our source code we named them task 1, task 2, task 3, they're really just being given incremental IDs. Sorry, what am I trying to? So, like the task subsystem starts off with task ID 1. Actually, I'm not sure why we have a 000. I think we messed something up.
No, we start with task 0 as the root.
Right. I'm not sure why we ended up with a 0 in there. I'm gonna undo my stuff. Well, it should be right.
So is the Git commit graph maybe better than the flowchart graph at expressing the remote ability?
Well, it's kind of like, what do we? It's yeah. The thing that the flowchart was going to be good at was being able to draw boxes around locations. That's the thing we lose with the other ones.
Yeah. Also,
for what we're trying to capture here, where it's all in one location, I really think the sequence diagram is actually the right thing.
So with the sequence diagram, you can highlight parts of the diagram, like
You
with
can still draw
rectangles.
boxes around it.
Yeah.
I don't think sequence diagram's it.
No.
Okay.
No, because
They really, when you see one, you really get drawn right back into the 90s.
well, the issue is sequence diagrams basically have a column for each task, but we have like a dynamic set of tasks that's growing and shrinking over time. So it just kind of doesn't. It's not a good fit because you can't pick a static arrangement of columns that makes sense. Sequence diagram makes sense if you have like two tasks that are communicating with each other, and then that's it. It's not good if you're like, oh, I reach a point in my program where I fan out 50 tasks and then join them back together, and then I do something else that fans out 30 tasks that are different tasks than those 50 because you can't, you know what I mean?
Yeah, that makes sense. Is the commit diagram that does it handle that better? I'm not that familiar with the commit diagram myself. Sort of like the short life cycle or potential short life cycle um, of the tasks.
I'm not sure, but I think Flowchart can do it. I guess why are we thinking that Flowchart won't cut it?
I guess one thing I think about when thinking about a lot of this distributed system stuff is that there's a bunch of immutable state transitions and like propagating forward of causal information. And I think maybe a structured Git graph kind of captures that. So, for example, like there is no real notion of time. I think that's easy to capture aside from causal ordering.
So
And I think, sorry, go ahead.
yeah, and it's sort of um, exemplified by the fact that we have to create multiple versions of the same root node, right? When working with the flowchart, sort of to fake the idea of later in time.
And I think it's also if we created the flowchart diagram, I think it's a little bit too much ambiguity about what the meaning of an individual node is and what the meaning of an arrow is, which allows that to be interpretable in ways that we might not desire. So people might create diagrams which feel correct, but don't actually model anything useful.
So the reason that I ended up choosing the flowchart graph diagram was because in my head I had the notion of like running tasks, tasks that are live that haven't been awaited are in a stack or like in a queue. And when the queue is empty is when you've got your root node, and that's kind of like your notion of causality. And that's when you would say increment a counter, or like that's the trigger to then create like a new point in time farther down in the diagram. Was like, okay, I'm looking to await tasks. I've awaited tasks. Is that sort of queue of running tasks now empty, or just the root? Now I know I need to kind of like branch out again. So that's kind of what I was thinking in terms of sort of loose semantics around drawing the drawing the flowchart. I don't know if that's correct, but because it
I think
might.
it makes sense.
Okay, it might
Yeah.
rely on some assumptions about like, can subtasks fork their own tasks, and then like what does that mean when they're doing their own stuff? But like that's kind of what I was thinking for
Oh,
the graph.
okay. If you think of the flowchart as okay, we do have to we have to make multiple copies of a task, but basically each node in the graph is an event. The And then the arrows indicate causality. Like if there's an arrow from A to B, it means that B happens causally after A. And then that's it. The labels are just to tell you basically what the event was. So it's really just visualizing, hey, this is the causal graph of your events that happened when you ran your program. And that's kind of it. That's why you see the same node, or that's why you will see the same node repeated, is that there's multiple events that happen at that node, and they appear at different points in the partial timeline order of events. So
One thing that might be difficult on the flowchart, just because of how Mermaid renders it, is sort of keeping the life of a single, this node that we've split up into many versions. Mermaid can kind of draw that wherever it wants. So we might not have a nice kind of like column of the tasks and being awaited, where all of the same representations of the node at different times, they all line up. They probably won't line up. They'll be sort of all over the place.
Yeah, I would think that in order to do that, you'd need a way to define a meaningful definition of distance between like nodes. And I can't off the top of my head think of a definition of distance which is intuitive, especially for more and more complex diagrams. I wonder if it might be a good idea to maybe go through the distributed Spark-like datasets blog post and maybe try literally diagramming those to find a kind of semantics that we want. And then once we found the semantics that we want, and we've checked that they obey certain properties, like consistency properties of the way that we talk about what nodes and edges and how to interpret them are, then we can back into interpreting the task tree into some format which is renderable into a diagram with the semantics that we want.
Yeah, I think the Spark datasets article uses slightly different remote abilities. It uses seek, and we define our own tree data type. So we might be modeling a slightly different or higher level kind of concept than the baseline forking and awaiting of tasks that is present here. Stu, are you muted?
Yeah, I was. Sorry. Just for fun, can we run like a fold with a seek, and actually, since we can draw diagrams now, can we just like actually see what that looks like with our little diagrammer?
We could, yeah.
Like, can we
We could draw the weird string diagram. Why not?
let's draw a diagram now.
wait, can we fix the like the actual? We need to have multiple instances of the nodes, I think.
Right.
We don't want to have this should be a DAG. It should not be a loop.
Yes.
There should not be like circular things happening, because that is not.
I don't know that we have a. I mean, I don't. Okay, how do we? All right.
I think immediately.
How do we do it?
Yeah, I don't think we ever know how to do that. But
yeah, well, let's figure it out.
I think one thing that I can see immediately is like the directionality that we want the fork and await arrows to go immediately creates our first loop.
Let's see. Let me go back to this guy.
Can you replay this? This is the wrong diagram. There was a bug.
Okay. You want me to rerun main 2?
Could rerun it real quick and replace it.
Okay. So
because root and 0 are backwards, and yeah, that's better.
Okay. Yes, this makes more sense to me.
Yeah, it's like This should look like those await arrows should be pointing down to another copy of root.
So at
And
what point should we have a new version of root?
that's my question.
It's literally every time you await.
So there should be 3 copies of root, right?
Yeah, there should actually be 3 because you await them in a particular order.
Like, is there a difference between we've seen this node before because it's forking and we've seen this node before because it's awaiting? Are those just 2 different versions of the node?
Yeah, and I think the semantic difference of seeing that new node means that we have more information. That node is in a state where it's awaiting for this other thing and waiting for this other task. So I think in terms of the like Git like diagramming, it might be, yeah, maybe we can capture some information about the state that that node is in, which would capture some combination of the things that it's currently awaiting on. I guess it's either in a state of computing some stuff or awaiting on some stuff. Like even a fork is like, well, actually, what happens after the fork? Does it just go on executing?
It goes on executing, but you don't know that, and that could change at any time.
Are those details of the
However,
remote
it got
pure
implemented.
handler?
Yes.
Okay, and we want to abstract that away, right? Like for the purpose of this diagram.
We don't want to capture that in the diagram.
Okay, so yeah, to me it seems like the only things that it can do is be in some computing state or be in some awaiting state, and forks just happen independently. And we would see the additional awaits as a state change, like a state transition into the awaiting state, represented by a new node, and then awaiting multiple things. And because the vocabulary that we have doesn't allow for like applicative awaits, we just see like a structured tree of awaits. So if it's awaiting on 6 things, it would just be like a long list of 6 connected nodes, which each have one single await.
Wait, why 6? It would be like 11 or something, wouldn't it? I don't know.
Or
I'm not sure we know what this. I don't know. Even for this small computation, I don't think we can agree on what the graph should look like yet.
so, Isa, are you saying that, let's say I have a root task and I fork 6 plus ones, 6 tasks, subtasks. And then when I call await, would the graph for that be like, of those 6, underneath of them, all of them have root, like 1 to 1? And that's their, I'm awaiting to the root. So
Initially, I would think so.
In your schematic here, forking creates a fork, but awaiting doesn't, like return to a notion of like I'm awaiting to this parent.
I don't know yet. Let me draw some things up.
Yeah.
I
think this is very, very interesting.
So for a second, I'd like to maybe think, okay, if we weren't constrained to these flowcharts or the charts that are provided by Mermaid, what would this look like? And would it look like basically a sequence diagram without the actual full lines, without the actual full life cycles?
Look like a sequence.
I'm not sure, man.
So we need like
because
the communal drawing software.
yeah.
So everyone can draw what they think this thing should look like.
So, maybe pull up any sequence diagram with some data in it. Maybe an example from the
This one?
one with actual like maybe
Like-
keep scrolling a little bit lower. Yeah, like here, this one. So now, if you imagine if we remove the the top and bottom rectangles, and the vertical lines,
Rem-
leaving just like the horizontal lines and the sort of like the horizontal rectangles, the little ones, representing the life cycles of the actual sort of request processing.
okay, so
Does that represent the remotability a little better, where you don't have these full life cycles where Alice and John exist from the entirety of the of the process, but basically John is created at the point at which that first arrow ends.
Right. That box represents its lifetime. That rectangle on the line.
Yeah. Is
I
that a good
don't,
representation?
I don't think that's going to be good. Imagine like parallel mapping over a list of even 10 elements. So you're forking 10 different tasks. You have this like, you're going to have 10 columns. There's just going to be like all these lines crossing each other to represent that forking, and it's just going to look like a total mess. You really do want the sort of DAG. I mean, you want something flowchart like. I think the only thing the flowchart is really missing is a way to, or maybe it does have a way of doing this, but is like ideally you could group the nodes so that you say like, hey, all of these tasks or all of these events basically happened on, the Rebecca node.
yeah, you can do that with the subgraph description.
Would that be a good representation if the regular flowchart could do that? So at the very least, we would always see root in the same alignment.
But I guess, well, it might depend on. I guess it might depend on the computation. Like there might be just like some vision. Basically, it might get really hard to lay out depending on what you're drawing. Like it might not. Okay, what am I trying to say? Like, let's take that example of like parallel mapping over a list of say 10 elements. So for sort of there's this point where you could basically have a bunch of things sort of explode out. But if you're always sort of constrained to like keep a single column available for like the place you're eventually going to join all those tasks back to, then that's sort of a constraint on the layout that might not produce good results. But I mean, maybe, I don't know, or maybe it would be good because things sort of move around less horizontally. But
And I was thinking maybe those columns could be reused once the life cycle of an individual thing ends. That could be reused for a new thing.
yeah, but things like the life cycle, like a node it doesn't often just completely end. It's just like it goes through a period of time where it's not forking tasks or there's more other tasks being forked. But then, sometime later that location might start forking tasks again. But yeah, I mean, I don't know. I feel like there's probably no perfect way of doing it, but
yeah, mostly I was curious because ultimately we could draw whatever we want on an actual canvas. It wouldn't be
yeah.
automatically rendered by the documentation, which is something that's really nice right now with Mermaid. But you know, I am curious too about what if we have the ability to actually draw whatever we want. Is there a good way to represent this?
Yeah,
That's a good point.
I would want, like, I like the subgraph thing of Mermaid. Or I mean, it's maybe a little too tricky to.
Rebecca, will you rerun it and re-render it?
Meanwhile, Stu is implementing stuff. Is this
Almost like what would be cool is you kind of just have this DAG of events, right? And of forks and awaits, and it's just sort of represents the causal graph of when those events occurred. But then the events also have a location, and it's like you want to just be like, okay, layout engine, you figure it out. Like, make some effort to try to group events at the same location into the same like visual part of the graph, but like maybe there's like some limits to that. Like it seems like it would be like you don't it's yeah, you want to allow it to maybe be a little bit flexible sort of at different points in time. You might, I don't know.
Something that might work would arrows, and Mermaid might try at that point to sort of keep those lines more in a straight line while having more freedom with the longer arrows.
Oh, wait. There's a concept of the length of the lines?
Yes.
yes?
Okay. Well, yeah,
So
that seems interesting.
it might not be perfect, but at least there'd be like a thread connecting all the roots. A thread, I mean, like literal line, like a line.
Try it again.
Yeah.
All right, but it would be a little weird because in this case, how would we connect all the roots here, all the ones with just zeros? Would it be I guess it would be a dotted line from the top left one to the bottom left one to the bottom right.
Yeah, also I think the second await should be below the or yeah, something. The second await should be after the first, or there should be some order to these two awaits.
We could represent that with the length of the arrow. We could say, an await that happened later, or there's a bigger span from the time. We could extend the arrow to force the node to be drawn lower for something that happened later.
I don't think it makes sense to have two zeros with one lower because
I
then,
know it's hard. It's
no,
hard.
not this is not a comment about the diagram itself, but like as a conceptual model. Because then which of the zeros then forks a third task in the in the
Like
next
when we're
step.
keeping track of what we've seen, it's like we have to know if we've I don't know. I was trying to do something where it's like if you await, I kick you out of the map, so we have to recreate you. So it would create a new version. But I didn't think that was going to create the extra ones.
Yeah, I think it's a stack of like, have I awaited all my tasks? If so,
Or it's like
then you
every
get
time
a root. Go
it's
ahead.
like if you haven't awaited yet, we create a new bubble for you until you fork again.
I could see that. That would do the sort of coalescing of all the awaits
Yeah.
that occur without an intervening fork. So that would give you like the diagram that you showed earlier that had looked like a diamond.
Right.
Can you do a little experiment? Can you connect those roots with dotted lines?
Oh, like
Just manually adding a, yeah,
So all of the zeros would be connected.
yeah. And dotted line is just without the arrow, but with an extra dash.
Wait, Stu, I want to write that idea down that you just came up with before we forget it. What was it? You create a new node if
whenever you await, we like kick you out. So we're going to create a new version, and that version is good until you fork again, and then it's like your next. Every time you await, we keep using the same one, but if you fork again, that's when we kick you. I don't know. That like it's like we need to stay stored in the map like your state, and it's like have you forked yet, or have you awaited yet?
I think I have an idea of something that might capture what you're talking about, Stu. So
wait, hold on. I just want to make sure I understand Stu's idea. Just one second.
Okay, so we have our map.
When you await
of nodes that we create. But along with our map of nodes we're gonna store a state with a node, which is has it forked or has it awaited. And it's like if they do an await and the last thing they did was await, we're fine, we're gonna reuse the node. But if they do an await and the last thing they did was fork, then we're gonna make a new one.
Okay.
Hey, Rebecca,
when you
share
I got can't talk.
Sorry. Can you share the link?
Yes.
When you await within task T,
we're gonna remember if the last thing they did was either await or fork.
If the last thing task T did was an await, then
reuse the node.
Then you reuse the node. Okay. Okay, if the last thing that T did was a
fork.
Then create a new node.
Create a new node, yeah. Then delete it from the map and create a new one instead.
Yeah. I like it.
So is it correct to say that that's allowing us to capture some applicative semantics by keeping track of forks, like multiple forks, without actually doing some processing work and awaiting in between?
Right.
Yeah, it's like it kind of, for instance, it doesn't really tell you the order of the awaits if you just have like 10 awaits that you're doing kind of in sequence. Yeah. And it's only if you initiate another fork that it'll kind of like, which is, maybe that's fine. I mean, there is like definitely going to be like way too much information in the full graph of like all events.
Right, this is for toy examples.
Yeah, so,
Don't flat map over, 5,000 elements in remote. Pick 5.
I think maybe we can also use sequence diagrams to just benefit from co-locating things on a single line. Like, at least, so visually to me, I think it would be convenient if all of the zeros, so by co-locating things on a single line, it at least means that all the zeros are mapped to the same like x coordinate, right? So just by virtue of that, I think like, so with like, if we want to express this computation of we fork 3 tasks and we await on 3 of them, let's see if this shows up at all. So we've got this task 0 up here. So this is if we had applicative semantics. So we fork to task 1, task 2, and task 3, and then we await all 3 of them right there. We also have kind of like more sequential semantics, I think is how the world that we're actually operating in. So this is an example of what Stu is talking about, where we fork and then we intermediately await. So task 0 forks to task 1 and then also awaits. So we'd express that as a state transition for task 0 to be in the awaiting state on task 1 that happened at least after the fork of task 1. So this captures the causal single-threaded flow of execution in task 0. Right? We know that its awaits must be structured and causally happen after another await. So it captures causality in that way, and the arrows are meaningful as causal message passing. And then we can also express forking to task 2. And we know that since task 0 forked to task 2 after, actually, I think I need to change this diagram a little bit. Give me 1 second. So we need to express this as, 1 sec.
Yeah, like I could see something, especially if you can, like, as you go down the, like, there's not going to be a static set of columns for like the whole trace, but if you could like have little like vertical blocks that maybe have like, I don't know, 10 columns, and then maybe they're done, and then you get to a vertical chunk that has fewer columns or more columns, and they have different labels. Like I could see something like that. It's just you don't want a static set of columns for like the entire thing. I think also the arity, like if you're mapping over even like 10,
Yeah, totally.
5.
I think it might be
things in
cool. I know we really can't do this in 2 dimensions, but it would be great if we could bring this into 3D, and then we have an extra dimension to co-locate things based off of their location. And then we can just like be like, hey, force layout, rather than draw boxes around things which are near each other, like co-locate things in the 3rd dimension. So that would give a meaningful definition of location that we can use. And you'd see these like spiders, like these strings hanging down with causal spheres and messages that go between threads.
Could we like explore it in virtual reality?
We need to add 4th
In, like, the
dimension,
metaverse.
time. We can actively dynamically draw it as it's running.
Well, we also don't have a definition of time because we every location and every node has its own thread of time and its own clock. So we don't have a meaningful definition of time aside from the location of events in their causal ordering.
Mm-hmm. Right. Right. I feel like Fabio was just talking about this, that like the ordering of events in a distributed system is a poset. It's a partial order, not a total order, because of the whole time problem. What was that?
Okay, so maybe. Sorry, did you guys have anything else? I was just sharing this one updated diagram based off of what we were saying. So here we have node 0, which spawns node 1, so it forks, and then also awaits intermediately. And then we see that this next fork to So the next fork of task 2 is coming from this instance of 0 because it's aware that the state transition happened. Like we know that this one transitioned to this state, and then this is the state that caused the fork. And then what else? If we wanted to represent 2 forks happening, and we didn't immediately await, and we awaited both of them after, so we have 2 forks and then an await, I think that could be represented by just kind of removing this intermediate state transition here, because it didn't necessarily go through state transition. The state transition would have only happened on completion of both of the awaits, which captures kind of the applicative semantics in the method that Stu is talking about by checking if we've done 2 forks. That's how we capture if we need to interpret this as something applicative happened, an applicative fork happened versus a sequential fork and await. But yeah, this would get pretty unwieldy if we did anything beyond 10 items. I do agree with that.
Yeah. I the wonderful thing about the handlers is there's no reason why we can't have multiple local draw handlers for remote. So, we could very well end up with, pick your path, like what is a good diagramming tool for your particular run. And, if you have a really small use case, maybe you could do this sort of sequence diagram style, or if you have a much larger use case, pick something else. Or you could even do like tracer, select a couple of your entire distributed system and then draw those so you don't get overwhelmed. So I think we have a lot of flexibility with the handler. And maybe next session we'll figure it out.
All right, rerun it one more time.
Okay. Well, we are at time, but we're gonna run. Let this be the moment.
There's like I've been ignoring y'all talking, and I actually implemented the thing.
Okay, this is what it looks like.
Oh, is that? Oh,
So close. We'll
close.
get something working next time.
Okay.
Yeah, we'll get it. But y'all, this has been super fun. I'm so excited. Everyone has such incredible ideas about how we should do this, and I'm just so jazzed by it. Yeah, we'll I'll send up what we have so far. I'll post a stream, and then hopefully we'll see y'all next week.
Thanks,
I got,
Rebecca.
Cool.
Thanks, y'all.
One more thing, if you guys have an extra 5 minutes, or you really got to go now. That's cool
I'm gonna hit stop recording real quick.